Hello everyone. Today is the 6th week of our class. Today's class is a little bit late. I'm sorry for that again, but actually nowadays I a little bit busy. So today is Sunday. So Sunday night I'm recording our class, and this video is recorded in my home. So the mic, the sound, and the camera a little bit different different. Actually, the sound quality may be bad compared to the previous video. So I'm sorry for that again. Actually, today's topic is about wrench. I will explain about wrench first, and then the contents of wrench is quite short. So after that, I will explain about the examples in the chapter 3. Actually, the summary of chapter 3 was done at the last week. So actually, we already learned about this kind of table, and we learned about the modern robotics library and the symbolic modern robotics library also I introduced here. So it might be helpful to understand how to calculate the modern robotics technique. And so this symbolic library may be more helpful about that. So in here, there is all the calculation process in here like this. So the result also symbolic. So it might be more helpful to understand the process of calculation. Actually, modern robotics library, the genuine modern robotics library is using NumPy. So the calculation result is only numerical. So it is hard to understand the process, middle of the process of calculation. So it might be useful, this package. Okay, let's start about wrench. As I already told you, our class, the main purpose of our class is to what? To express rotational motion and translation of motion together. Yeah, that is our main purpose in our class. Similarly, in the force, there is two main component. One is force and one is torque. This is about linear motion. This is about rotational motion. So these two concepts can be merged by wrench. So wrench including force and torque. So we know about the torque here. So force multiplying moment arm length become torque. So more general expression about force and torque is wrench. So wrench including these two things. So this concept is more general expression. So let us think about the A coordinate. There is moment arm vector RA here, and there is a point R, and there is a force F here. In our textbook, the wrench, the torque was written by character small m. Usually we use tau for the torque, but in our class, in our textbook, we usually use m. Maybe it is the related to the moment. So in the moment, they use m. So we in our textbook we use m. So this one is same meaning. This one is have same meaning of torque or moment. So in the scalar value, we can simply write R multiplying F, but more strict expression is distance cross product force. So momentum cross product force is torque. There is moment, yes. So just as twist, twist having linear velocity and angular velocity. Just as twist, we can merge the moment and force into a single 6-dimension spatial force. So the other name of wrench is equal to the spatial force. So wrench equals spatial force. Spatial force. So in the wrench, there is basis coordinate. So in this case, the basis coordinate is A. Depending on the coordinate system, the direction is changed. If we take this A frame, the direction of X, Y, Z is like this. But if there is another coordinate, like B, in here, X, Y, Z coordinate direction is different. So the vector expression in 6-dimensional coordinate, 6-dimension vector, the base frame is very important. So depending on this, the meaning of this value is different. So in here, the base frame is A, and the wrench is written as some large capital F. Not same one. Actually, the wrench is written by some kind of symbol similar to F, but not the F. Okay, let us show those. Yeah, this one is wrench. very similar to the F, large F, but a little bit different. So this one is wrench, and wrench including moment and the force. So this one is 6 by 1 vector. The moment is upper 3 by 1 vector, and force is lower 3 by 1 vector. So this one becomes wrench. Okay. So because the wrench is depend on the coordinate system, if the coordinate system is changed A to B, this value should be also changed depending on the base coordinate. In the case, we can use the transformation, homogeneous transformation matrix. Let's see about this. Actually, the work or the power is the physical, having the physical meaning force multiplying velocity. In our case, the force is spatial force, wrench. In our case, the velocity is spatial velocity. So this wrench multiplying spatial velocity, it means this one is twist, and this one is wrench. Wrench multiplying twist equal work. And the work is not changed depending on the coordinate system. So this one, actually, this one is 6 by 1 vector, and this one also 6 by 1 vector, usually 6 by 1 vector. So 2 multiplying this one, we are transpose this one. So spatial velocity transpose wrench equal in A frame and also B frame, because this one is work. Work is independent on the base frame. So using this relationship, we can calculate the relationship between FA, range A, range B, there is a TAB. So how can calculate this one? So we know the other joint. Yeah, the A coordinate, the B coordinate can be related by other joint matrix here. And we input this one here, and then we can write down like this. And by calculating this one, we can make this equation. So when the transpose is into the go into this here, then the position of these two things is changed, and we attach it the transpose here and here, so it become like this. This one is general calculation method about the transpose. And by checking this equation and this equation, we can conclude this one is same, this one is same as this one. So resultantly, we can get range B equal other joint transpose FA. The transpose go into here and the A and B is changed. So as a result, we can get the range B other joint TBA range A. So the A here, B here, B here. So we can change the A and B. So finally, we can get this equation. So as you can see, this form and this form is almost the same. So we can easily memorize about this one. So the twist, some twist in B can be transformed to the twist in A using other joint TAB. The same thing can be done in the wrench. The wrench in the B frame also can be transformed into wrench in A frame using other joint TAB. Yeah, this one is about the wrench. Actually, the concept of wrench usually using on the statics. Actually, when you run about the equation of motion or some rigid body motion, we learn about the statics first, and then we learn about dynamics. Similarly, we learned about the wrench for the static calculation. This example about the statics. Actually, there is an apple in here, and there is a gripper in here, and there is a robot arm here. Middle of that, there is a sensor, post-hoc sensor. This one is post-hoc sensor. So this example is about how much force will be applied in this sensor due to this apple. So apple is 0.1 kilogram, and we assume the gravitational acceleration constant is 10 meter per sec square, and hand is 0.5 kilogram. So let's do this one. Because the wrench is 6-dimensional moment and force. So we usually using this kind of 6x1 vector, or we can use simply the list type. So when we using the Python calculator, it is easy. It is more easier to using list type. So we can write down moment here and force here. So this one is this is about moment. This is about force. In H frame, based on the H frame, this one is mx, my, mz, and fx, fy, fz. Because there is gravitational force here, due to the hand, the central mass of a hand is having same origin with the H frame. So there is no moment in here. But in the case of the mass, there is a hand mass. So in here, there is 5 Newton here. So this one is minus y direction. So it becomes 0, 0, 0, 0, minus 5, 0. In the case of apple, this one is about the hand, and this one is about the apple. Apple is the coordinate is on the center of the apple. So there is also no moment in here, and because this one is 1 Newton, and this one is same direction with z, so this one becomes 0, 0, 1. So, and then we can get the homogeneous transformation matrix in the homogeneous transformation matrix HF can be easily calculated by using our intuition. Let's think about H2F here. This one is the position vector from here to here. So, and also this H is the base frame. So in here to here, the minus x direction along the minus x direction, it goes about L1. So this one becomes minus L1, 0, 0. And the direction of x in H frame and X frame is same, and also the Y frame is also same. So Z frame is also same. So it becomes identity matrix. So when you think about the homogeneous transformation matrix, you can make this 4x4 matrix by using your intuition. And secondly, from A to F. Here A to F. So the base frame is A. So minus x direction, L1 minus L2 here, and 0, 0. And then the direction, this x direction, based on the XA direction, XF direction is having same direction. So it becomes 1, 0, 0. And Z direction, ZA direction, having same direction with Y direction. So this one is X, this one is X about X, this one is about Y, A, this is about ZA. So ZA equal Y direction of F frame. So it becomes 0, 1, 0, because this one meaning X, F, Y, F, Z, F. Because it is equal to the Fy, it becomes 0, 1, 0, 1, 0. Similarly, the y-axis, because we are using right-hand rules, because the z-axis is in here, when we using the sum direction is z and x is here, it should have the y direction become y here. The y direction is came out of the screen. So y direction is equal to the z direction. No, because xy here. xy, so z is came out of here, and xy. Y and x having same direction. I think this should be 1. Let me check about this one. It is minus. Okay, let us think again. X direction here. The y direction should be came out of here. XY. Yeah, it should first one. I think the textbook is a little bit the textbook having some error. Let me check about this. Okay, to check about this, we should use the Python library. Okay. Okay. Okay, let us think. Using Python library, import symbolic modern robotics as SMR. So there is this kind of library. Okay. In here, import impy as S, and using S matrix, let's make T (1, 0, 0) minus 0.1, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. We need comma. Yeah, it become THF. So we name this one THF. Okay, by using like this, you can check the value of this one. And similarly, let's make TAF 0, 0, 1, 0, 1. This one become 2, 5. To make other joint, actually in our Okay. In my symbolic calculation package, the other joint is not yet programmed. So let's use MR, import modern robotics as MR. Okay. Help MR. TIR MR. Okay, there is other joint here. So help MR dot other joint. And we can check how to use the other joint T. Okay, let's make T again. In the MR, in case of MR, we should use the NumPy. So let's import NumPy also. Okay, NumPy is also included, imported. And okay, firstly, THF. Let's change NP away. Okay. Oh, it is very simply done. Okay. Let's change this one. Yeah. Okay. Then other joint ID T H is calculated by MR dot other joint T H F. Let's check the actual value. This one. Yeah, this one is other joint THF. Similarly, other joint AF like this. Then we can calculate this one. So we should calculate spatial force at F frame. So this equation can calculate the spatial force in F frame. So firstly, this one, firstly we should make array 0, 0, 0, 0, minus 5, 0. Okay. Similarly, P A 0, 1. And then let's calculate this one is 6 by 6 matrix, and this one is actually 1 by 6, maybe. So if we just multiply like this, it should something weird. So we should use this one. This one is in Korean. We call this one as 골뱅이. In English, apostrophe. No. How call it in English? This symbol is located number 2, keyboard number 2, if we press shift key with 2, we can use this one. So it become like this, and also plus A. Okay. Okay. This is a little bit different. If we use this one as minus, okay, this is not exactly what we want. This is not we want. Okay, let's think about this. What is wrong? For this one is like this, and we should 6x1 vector. So actually, this one is horizontal array. So we should transpose in here at t. Transpose. What is the transpose in NumPy? NumPy transpose. Okay. NP NumPy FH win. What is this? As I know, we can use this dot t. Okay, let's use dot t. For h, this one is something like this. Dot t. Oh, it's weird. Actually, maybe we should use this one. So if we make it like this, zero, 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 -5, 0. Yeah, actually this one is vertical vector FH. Okay, let's multiplying CHF FH with this multiplication. And zero, 1, A. And plus Oh, the same result came here. Even though we use this one, we are having same result. I don't know why. Okay, what is wrong? Let's check. 1111. That's right. Okay. All the joints. This one. Ah, okay, okay. We calculate TAF, but in case of other joint, we should use TFA. Yeah. So there is different. So, okay, okay, okay. Okay, okay. Let's try it again. We should use the inverse of this matrix. So in the case of inverse homogeneous transformation, here, trans inverse. So we can get the inverse of homogeneous transformation matrix. So like this, and we can get FA. Okay. So we should use this one. Okay, and we don't need to this one. Okay. Yeah. Oh, same result. How about this one? This is in here we should also use FH. I'm sorry about that. In here we should use also in the inverse value. Yeah. Okay. Let's try again. What is wrong? HF FH. Okay. How about this one? Let's make it 1. It is very weird. In here, HF. It is right. AF. It's correct. Inverse. Inverse. And then using inverse, inverse. How about -1 here? Even though in this case there is no torque in here, I don't know why. Let's try again. Wing. Oh, okay, okay. That's right. Mm hmm. Okay. Finally, I got what is wrong. Oh, I'm sorry about that. Okay. Actually, this is not the correct rule. This cannot be go inside. Yeah, we should use just transpose in here. So this is not the same one with this one. So in the case of other joint, we can write down like this or like this. But this transpose not go into the homogeneous transformation matrix. So yeah, because there is no special meaning about homogeneous because the homogeneous transformation having some rotation matrix in here 0, 0, 1 and position matrix. So the transpose of this one is not the homogeneous transformation. So this is not the physical meaning. So it cannot go into here. So there was my error. So this is not right. And this one is also not correct. This is not correct. So and this one is also should like this. Okay, let's try again. Based on this one, okay, yeah. THF like here and TAF here, and we should calculate THF and adjoint HF. And here we should AF here. Okay. Run, 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 run. And run, run. When we calculate here, we should use transpose here. And also we should use transpose in here. Yeah, then it becomes like this. Okay. I think this should be 1. Oh. Again, the calculation, there is an error in calculation. We didn't erase the inverse here. Okay. In the case, minus here. Yeah, then it becomes the same one here. But I think this one should be 1 because A and F, A and F, A here, and y-axis should be came out of here, and the z-axis in F, x, y here, then came out here. So it should have same direction with z direction, so it should be 1. I think it should be 1. Okay, this one might be correct, and this one is false. Okay. Okay. Based on F frame, let's check out again. Based on F frame, there is X, F, Fy. So in case of force, there is 5 Newton here and 1 Newton here. So it should 6 Newton here. Yeah. So the result should be -6. This one is correct. This one is correct. But I don't know why this one should be -1. Because the jet y direction is here and z direction is here. Okay, let me figure it out. I will having some break time. Okay, I will come back.